Hello everyone, I am Chokijamso and we will be presenting on the working principle and the construction of a three-phase induction motor. So basically I will be talking about the construction of a three-phase induction motor. Before going to the construction, let me explain what is the three-phase induction motor. So three-phase induction motor is a machine that will convert the electrical energy to the mechanical energy, and this three-phase induction motor will use two types of rotor, that is slip ring rotor and the squirrel cage rotor. So the slip ring rotor is also known as wound rotor, where the windings are linked with the external resistance, and by varying this external resistance we can change the torque of a motor. Now when it comes to construction, it has mainly two parts, that is stationary part, that is called known as stator, and the rotating part, that is known as rotor. So stator part is the stationary parts of a motor, as I have mentioned earlier. So in this stationary parts of a motor, there is a three-phase winding placed in the slot, that is placed in the stator, and these three-phase windings are connected either in star or delta. And secondly, the core of a stator is made up of laminated silicon steel, mainly to reduce the eddy current loss, and which will result in high efficiency of a motor. And the outermost part of the motor is known as the stator frame, which will protect the stator and the inner parts of a machine, and it is made up of cast iron. And the rotating part of a motor is known as the rotor, and it is laminated with high silicon steel. As I mentioned earlier, this high silicon steel will reduce the eddy current loss and increase the efficiency of a motor. Then it has a rotor slot where the conductors are placed, and the rotor conductors are mounted on the shaft of a motor, and this this motor shaft, it will convert the electrical energy into the mechanical energy. And the rotor conductor connects the end rings of a rotor, and it is not parallel to each other, because this will reduce the cocking effect and noise in the motor.
Now to continue with the presentation, I'm going to explain on the working principle of electromagnetic induction motor. As we all know, there are two parts of induction motor, that is rotating part and the stationary part. That stationary part is known as stator winding, and rotating part is known as a rotor winding. So whenever three-phase AC source is supplied to the stator winding, the rotating EMF is established around the stator, and this rotating magnetic field rotate at the speed known as a synchronous speed. And as we know that synchronous speed is given by the formula Ns is equal to 120F divided by P, where F is frequency and P is the number of poles. So this rotating magnetic field in the stator winding cuts the rotor conductor, and EMF is induced in the conductor of a rotor side according to the Faraday's law of electromagnetic induction. And this rotor conductors remain connected with the end rings so that it forms a complete circuit. Like as shown in the figure below, the two end ring remains connected and give a path for the current to flow through. And due to this induced EMF, the current circulates in this conductor and another EMF is created. So as we all know that when the current carrying conductor is placed in a changing magnetic field, the conductor experiences an external force. So therefore the rotor experiences a force when the torque acts tangentially on it and moves along the direction of the magnetic field. So this is how the electromagnetic induction motor works, although the stator winding and rotating windings are not electrically connected together.